Young people, welcome back. Chapter 11, lesson 8. We are deep into this chapter 11, guys. And I know you're loving it. I'm loving it too. But we got a real one. Let's see what it's about. Chapter 11, lesson 8, rational equations. Yeah. Big old fractions, right? So rational equations, the objective that we have here is number 1, solve rational equations. And the second objective, use rational equations to solve problems. So you always love when it has that second one. It basically means like a word problem. We ain't gonna worry about that. Let's get our practice in, right? So swap back. Students will be able to solve rational equations. The concept, rational equations, and the skill, solving. Yeah. So we're gonna have a whole lot of skills we're gonna have to bring into this to make sure that we're successful with it. Some of those skills being knowing what the big one is, knowing how to cross simplify, knowing how to collect like terms, knowing how to use distributive property, knowing how to get a common denominator when your denominator is more than a single term, right? It's actually a binomial. So those are things we've done already in chapter 11. I'm just excited that you're here with me. Let's get this bad boy started. All right, guys, nice lesson. We got 19 questions. There's that word problem that I mentioned. And just a heads up, guys, these problems take a lot of space. It's a huge fraction. And we gotta have the room, so don't be worried if things get moved or shifted around a little bit throughout the video, because my editor's gotta do what he gotta do, I gotta do what I gotta do, so that you guys can learn from watching this. But first one, solve each equation, state any extraneous solutions. So throughout the whole handout, guys, I'm probably gonna forget to do that once or twice, but this was from earlier. C cannot be what? 0, right? And C cannot be -3. But moving on to actually doing the problem, right? We're gonna go ahead and find the common denominator here. You could also cross multiply. I mean, treat it like a proportion if you like, but not here, guys. What I'm doing is I'm gonna go ahead and be able to solve this by taking the common denominator and just taking the C and C plus 3 and multiplying it by both sides. So what's happening is, by multiplying both sides by those two denominators, what I'm considering and what I'm calling a common denominator right now, it's going to cancel things out. You notice that the C cancels with the C on the left side of the equal sign, and the C plus 3 cancels with the C plus 3 on the right side of the equal sign. And then, of course, 2 times C is 2C, and of course, 5 times C plus 3. There it is. Now, if you notice, guys, that is simply cross multiplying. If I showed the cross multiplying, you would have got the same thing, but we got to get used to recognizing our denominators. Distributive property, 5C plus 15. Subtract 5C from both sides, and of course 2C minus 5C would be -3C. So if 15 is equal to -3C, you divide both sides by -3, and you get C is equal to -5. Got it. And again, how do we do that? Well, we could have cross multiplied, but no, we went ahead and multiplied both sides by the same value, and that value was a common denominator that we found. So for number 2, again, I got 3Q. 3 divided by Q, so a huge difference, right? Different operation, is equal to 5 divided by the quantity X plus Q plus 4. So again, cross multiplying would be just great here, but getting us, again, used to what's going on. Well, I got a denominator of Q and a denominator of Q plus 4. Well, I'm gonna multiply one side by that. I'm gonna multiply the other side by that and see what happens. And no invisible one yet, meaning I'm not putting on the left side Q times the quantity Q plus 4 over 1. I'm assuming and knowing that there's a 1 underneath it. What do you know? So unlike number 1, I didn't do it, but number 2, I went ahead and did it for us, right? So top times top, bottom times bottom, and we, cancel out the Q's, right? So just 3 times Q and 3 times 4. On the other side now, it's just 5 times Q, because the Q plus 4 in the denominator cancels with the Q plus 4 in the numerator. So again, solve now that you got variables on both sides. 3q plus 12 is equal to 5q. When I subtract 3q from both sides, I get 12 equals 2q. Therefore, 6 is equal to q. So in the first two, guys, all I simply did was take one denominator and the other denominator and use those two terms, those two factors, those two values, and use them to make sure that I canceled out the denominators that was keeping me from having this be a simple solution, right? So for number 3, I got the same thing going on. 7 divided by the quantity m plus 1 is equal to 12 divided by the quantity of m plus 2. So again, I could cross multiply, right? And just say 12 times m plus 1 is equal to 7 times m plus 2, but that always isn't going to be the case when you're solving your rational equations, but it can work here if you think about it as a proportion, all right? There's one fraction, there's another fraction, they're set equal, that's a proportion, cross multiply and divide. I'm sorry, cross multiply and you could solve it. But we're using the technique of that common denominator. So m plus 1 and m plus 2, I'm gonna multiply that on the left side, and remember what I do to the left side, I have to do to the, don't you let it, right side, exactly. So on the right hand side, the 12 divided by the quantity m plus 2 is now being multiplied by m plus 1 and the quantity m plus 2. Now, what simplifies, right? I didn't put the invisible one on the right side, I'm just like, let's go. So 7 times m plus 2, because the m plus 1 in the numerator cancels with the m plus 1 in the denominator. The m plus 2 on the right side in the denominator cancels with the m plus 2 in the numerator, and therefore 12 times m and 12 times 1 gave me that 12m plus 12. Let's go ahead and get our variables on one side. So subtracted 7m from the left and right, leaving with 14 is equal to 5m plus 12. And here, guys, two-step. And recognizing my two-step, you can absolutely, 9, what? Should be 2. Yeah, 12 minus 14 is 2. 2 is equal to 5m, and divide both sides by 5, and I get 2/5 for my solution of m. All right, guys, so same process. We've got another one of these. Looking at it, I've got the equal sign between them. And with the equal sign between them, my brain is already thinking, okay, I got a denominator of x plus 2, then on the other side, I got a denominator of x plus 8. Oh, okay, I can get rid of those, all right? Oh, I'm finally saying what m cannot equal. M cannot equal 1, m cannot equal -2. So that was in the directions. Make sure you understand that. We went over that. I think it was chapter 11, lesson 4, maybe 5. I'm not sure. But the meat and potatoes, the solving, the using the binomials, right? The canceling out, right? So let's get to it. I don't think we want that there. There we go. Number 4, 3 divided by the quantity x plus 2 is equal to 5 divided by the quantity of x plus 8. So again, a binomial and a different binomial in my denominators, I need to get rid of those. I'm not in the practice of solving these with those binomials in the denominator. So what am I going to do? Well, first of all, I need to write it correctly. See, it says x plus 2 and x plus 2. That ain't right. Fix that. And again, I'm doing a better job of writing my extraneous values. X cannot equal -2 and x cannot equal -8. But now I'm ready to go. Meaning, one denominator, x plus 2, multiplied by the other denominator, x plus 8, is what I do to one side. And the reason why is I know it will cancel out the denominator, leaving me with no fraction, right? That's the goal. On the right-hand side, 5 divided by the quantity of x plus 8, I'm going to multiply all of that. I didn't like that 5. Sometimes the 5 looks like an S. Nothing needs to be said. Times the quantity x plus 2 times x plus 8. So again, taking one denominator, taking the other denominator, finding the product. Really not finding the product because I'm not actually multiplying them out, but just using those two to know that I can simplify some. Sorry, I can cancel out the denominator in this equation. So no more denominator because the x plus 8 is going to cancel with the x plus 8, leaving me with 5 times x and 5 times 2, which will give me an easy 5x plus 10. On the other side, your x plus 2 in the numerator cancels with your x plus 2 in the denominator, leaving you with 3 times the quantity of x plus 8. So 3x plus 24 is equal to 5x plus 10. Again, going back to chapter 2 or 3, solving a multi-step equation with variables on both sides. We're going to go ahead and subtract 3x from both sides, leaving you with 24 is equal to 2x plus 10. Go ahead and subtract 10 from both sides. 14 is equal to 2x. X must equal 7. And of course, guys, we can go back and check because it is an equation. And the equation says what's on the left is equal to what's on the right. So I would go back, plug in that 7 for x, and verify that, yes, it does work. But they didn't ask me to do that. Number 5 and number 6, guys. So again, looking at something similar, except now that binomial is stretched out down to the numerator of the second one. So y divided by y minus 2 is equal to y plus 1 divided by y minus 5. So my brain is seeing the same thing, and I'm thinking, am I doing the same thing? Yes. Do not want those binomials in the denominator, so let's get rid of them. On the left-hand side, we're going to use denominator 1 and denominator 2, y minus 2 and y minus 5. Multiply that by the rational y divided by y minus 2. Now, if you notice too how I'm writing it, I'm making sure I'm having room to put it in there to show my work. And then on the other side, it doesn't matter because I'm going to the right. I got the whole paper, right? But you notice on the left-hand side, I made sure I could fit in those two binomials. So now on the right-hand side, same thing. This is always going back to what was said to you in 6th, 7th, and 8th grade. What you do to one side, you have to do to the good other side, right? So we multiply the left side and the right side by the same amount, so it's still an equal equation. By doing that, now I can cancel out these denominators. The y minus 2 cancels the y minus 2. So now y times the y and y times negative 5. Y squared minus 5y. On the other side, the y minus 5 cancels with the y minus 5. And of course, y plus 1 times the quantity of y minus 2. You mean I need to multiply binomials? Yes. So here we go, guys. Y squared minus 5y is equal to y times y. Y squared. So going back to the box or foil. This is, again, like I said earlier, guys, we're solving rational equations. You're pulling all types of skills out your back pocket. Y times y squared. Y times negative 2, negative 2y. 1 times y is 1y, and y times negative 2 is negative 2. So out of those 2 terms times the other 2 terms, I got those 4 terms. Now let's collect like terms, right? Y squared minus 5y is equal to y squared minus, catch up. Am I moving things to the other side? Oh, well, pause. All right, we're pausing because if you don't know how an equal sign works, somebody needs to stop and tell you. 2 equals 2, right? What if I take the 2 on the right side and put it on the left side? Then what will I have? 22 equals, no, not 22. It'd be negative 2 plus 2 equals 0, right? Because by moving it to the other side, it becomes its opposite, right? So understanding how the equal sign works, whether you're dealing with terms, integers, whole numbers, it doesn't matter, guys. That's why I'm a big component of repetition. Do it so much you ain't gotta think no more. And hopefully it'll become a little easier. So what's happening here, guys, is I'm just gonna go ahead and say, hold on. I got all these terms on the right side. Well, why don't I just put them on the left? I know I'm gonna have to collect like terms anyways. So where there was a positive y squared on the right, I moved it over to the left. That's why it says negative 1y squared. Where you have a negative 2y on the right, well, guess what? I'm gonna move that to the left to make it a positive 2y. And then of course, one more, because these are all y terms, right? 1y, the positive 1y, well, guess what? I'm gonna move that to the other side too, but when I move it to the other side, it's the opposite. So it will be the negative 1y on that side. So instead of me just letting this play out and letting you see it, me talking, I wanted to slow down and make sure that that was something that wasn't gonna confuse you, because a point of confusion, let's say that again, POC, a A point of confusion is what we're trying to help you with in these videos, guys. So I don't want you to get one over something so simple as moving something from the right side to the left side of the equal sign. Boom, let's hit it. So, positive 2y, and then of course a negative 1y, and now equals. So the only thing I left on that right side was the constant, the regular old number, negative 2. So now I got all these terms I can collect. Well, look at that. Don't tell me I'm not good. Oh, I wrote it underneath in blue, y'all. So negative 1y squared, positive 2y, negative 1. I gotta, subtract it and get it to the other side, however you want to say it, right? Showing my like terms, y squared negative y squared, or negative 1y squared. Got a negative 5y, positive 2y, negative 1y, so that's negative 6y plus 2. What? Oh, one at a time here, huh? Negative 5y plus 2y minus 1y. No. Negative 5y plus 2y is negative 3y. Then when you subtract another negative 1, when you take away another 1, you should get 4. Thank you very much. Negative 4y is equal to negative 2. So let's divide by negative 4 and both sides. And you get a fraction. Right? We got fractions all day on this handout, right? So y is equal to a positive 1/2. So again, guys, a lot going on there. You see how things got shifted, moved around a little bit, but hopefully you were able to keep up with all of that. And it's not over. So it's only gonna get more challenging. And like I said, guys, we got full video here, but nothing's changing in number 6. They're just continuing to step it up a notch. Binomial in the top, binomial in the bottom is equal to a binomial divided by a binomial, right? So b minus 2 divided by b is equal to the quantity of b plus 4 divided by the quantity of b plus 2. So again, I'm just gonna use that common denominator to cancel denominators. I don't want a fraction when I'm solving. So multiply the left side by the 2 denominators, b and b plus 2. And then on the other side, same thing. Because what I do to the left side, I have to do to the right side. So once I write the original equation, b plus 4 divided by b plus 2, times, and here we go, b and b plus 2. So b and b plus 2, b times b plus 2, b times the quantity of b plus 2. It's all in how you deliver it, right? But seeing it, understanding it, and being aware of what's really going on is going to save you from just making those little mistakes, right? So I'm going to go ahead and simplify b plus 2 in the numerator with my b plus 2 in the denominator. Now, of course, b times the quantity of b plus 4, b times b squared, 4 times b, 4b, and there we go. What about the left-hand side? So over here on the left-hand side, guys, again, I just need to get rid of the b. So the denominator had a b, and now the numerator has b because I put it there. I put it on both sides intentionally, right? So the b's cancel, now it says b plus 2 times b minus 2. So binomial times a binomial, we just did that before. And again, are you using the box? Are you using foil? Whatever you want to use, right? And in this situation, b to the 4th, no, b squared minus 4. So guys, that's the difference of 2 squares. Again, the more you play around with this algebra, the more it just becomes second nature. It's like speaking a different language, right? So that difference of 2 squares, or that b squared minus 4 is now equal to b squared plus 4b. Well, guess what? Remember that thing about equals? Well, guess what? Those two cancel each other because 2 equals 2. B squared equals b squared. They're going to cancel each other. Because if I were to subtract b squared from one side, subtract it from the other side, they would cancel each other, right? So now, divide both sides by 4 because negative 4 is equal to 4b, and of course, negative 4 divided by positive 4 is just negative 1. B is equal to negative 1. That's a great problem, guys. So if you can handle that one, you are doing outstanding. But that's only number 6. So I'm loving it now, guys, because there's a little bit more going on. And this is actually going to be a little bit of discussion. No need for a pause, but definitely want to point out, I got 3 denominators now. I got 2, I got 4, and I got 8. Well, this goes way back to what I used to love to do in junior high. Bust out that fraction. You don't like fractions? Bust it out. Just come with it, just go pop, pop, pop. 3 punches, pop, pop, pop. Bust them out. But what number is gonna bust out that fraction? Well, I need a number that 2 will go into, a number that 4 will go into, and a number that 8 will go into. Well, guess what? 8's that number. 8 times 3m is 24m. 8 times 1 is 8. And 8 times 10m is 80m. So now this by, and again, when I do it to the left side, I'm gonna do it to the right side. That's why you're seeing that distributive property go to the first 2 terms and then going all the way across to the other side of the equal sign. So whether I do it to the left side and the right side like I did with 1 through 6, doesn't matter. I just know what I'm doing. You need to know what you're doing. So, busted it out. 2 goes into 24 12 times. 4 goes into 8 2 times, and 8 goes into 80 10 times. Now I'm looking at it going, that's it? Yeah, that's it. All right. So, solve your equation. 12m minus 2 is equal to 10m. I get my variables on the same side. So, it's okay to have a negative variable term because I have a negative constant. So, negative 2 is equal to a negative 2m. Divide both sides by a negative 2. And I get the solution of m equals 1. Boom, bang, pow. Right. So again, guys, not complicated when I know how to bust out a fraction. If I don't want a fraction, I need to place something in the denominator I need to place something in the numerator that the denominator can go into. And that's why I chose 8. So moving on to number 8, all right? This one, I've got 7g divided by 9. Plus 1/3 is equal to 5g divided by 6. So again, my brain goes, huh? What? Oh, get rid of the denominators. What's gonna bust these out? Well, what number can 9 go into, 3 go into, and 6 go into? I tell kids, start with the biggest number, 9. 9 has to be able to go into 9 at least, right? Well, 3 goes into 9, but 6 doesn't. So what's the next number after 9? 9 times 1, 9 times 2, 18. Well, will 18 work? Well, 9 will go into 18,